Hey guys, welcome back. Now another video. I have not uploaded in a while, so I thought I'd make this video because I've been having trouble doing double interpolations. So I'm going to show you how I deal with this double interpolations in thermodynamics. As you can see here, we have this is thermodynamics because we have the properties of superheated water vapor, but this can work for subcooled liquids or any other table that has this. We're trying to find a number. In this case, as you can see, we're trying to find the internal energy in kilojoules per kilojoules per kilogram, which is here. And the two properties that they give us are pressure and temperature, as you can see. But in the tables, we have superheated water vapor, and as you can see, we only have 0.06 bar and 0.35 bar. So what I like to do first of all is, when you're given pressure, I just convert pressure to bar. And since I've been doing this for a while, I know that 100 kPa is 1 bar. So we just move this 1, 2. So it's roughly 0.20 bar. And as you can see, we do not have this in the tables. So we need to double interpolate. And I'm going to show you how I do it, because in my textbook and my professors, as you can see on this screen, this is the formula that they like to give us in the textbook. And sometimes I find that very confusing. I know it's easy for some of you, but for me, this is what works best for me. And I couldn't find a video on it, that's why I'm making this video. So let's begin. So we know that pressure is 0.20 bar, temperature is 95 Celsius. So let's get this out of the way. So now we need to find this temperature in between this two. How do we do that? Well, okay, first of all, the way I like to tackle this problem is, we know that this temperature is right in between these two temperatures, correct? So that means that we need we have pressure, that out of the way, pressure 20, right? And we need at this temperature for this pressure, and at 120 we need another one in here, and we already have the pressure, but we need to find this internal energy with the 95 that they give us already. So this is our goal, is to do this. We're gonna have a 0.02 bar, 80, 95, and 120. This is temperature, and this is internal energy. So we need to find this one, and then lastly this one. Right. So let's begin. The first thing we're gonna do is we need to find the 0.20 bar at 80 temperature. So how we do that? This is how we're going to do that. We keep 80 Celsius as a constant. And what do we have? We have bar, pressure. What else do we have? Internal energy, right? Because our internal energy is this one for 80, and we have internal energy for this one. Do I need to find this one? Correct? So it's going to look something like this. So 80 is constant because we're looking at that temperature. Pressures doesn't really matter here because they're all of them. You can use bar or MPAs. I just like to keep it simple and just keep it in bar. So 0.06, 0.02, and 0.35. I'm mistaking. That is. I'm just checking that it's 20. Okay. Oh, sorry. This is not 0.2. This is 20. Mistake. This is bar. Yeah, make sure you. This is. This is 1 bar. Yep. This is right. Okay, that's what I thought. So as you can see, we're in the middle. Our first number here is 2487.3. Oh, make sure you write your units, kilojoules per kilogram, and this is bar. We don't know what this is. And we have 2483.7 for our pressure at 3. So just a reminder that we're keeping 80 as a constant, and we have these tables now. So here's a formula that I use all the time. As you can see here, this is the formula that they give you in the book and most professors use, but this is the one that I use. It's the same thing, just written in a different way. It's basically the number you're trying to look for, the y lower, plus, this is the slope, this is the x of this value that you're trying to find, minus the x lower. What does that mean? Let me show you how this works. We're trying to find this number, right? So this will be my y. What will be my y lower? So I make this my y and I make this my x. So where's my y lower? My y lower is 2487.3 plus, what is my slope? Slope is 1y, x2, x1, correct? I like to do this 2, 1. So 2483.7 minus 2487.3 over 0.35 minus 0.06. Because this is my 1, this is my 2, this is my 1, right? So we have this, and then this x is corresponding to this y. So these two are the ones. So what does that tell me? That tells me that this is my x. 0.2 minus the one that's lower. The lower one is 0.06. So we plug this in the calculator. 2487.3 plus. Make sure you have everything set up in the calculator correctly, or do it by parts so you don't have a weird number. 0.35 minus 0.06, 0.2. I have 2485.56206 kilojoules per kilogram. This is my first answer. And how do you know you're right? As you can see, this number lies in between these two numbers, so that's right. Now we have this one, we need the other one. So we do the same thing. We keep 120 as a constant. We use pressure and internal energy. So this will be our same format, but we have 2544.7 for, oh yeah, make sure you write your units so you won't mess up. And I know professors like to check units all the time, so make sure you have your units. And we have the 120 internal energy. Oh, this one right here, 2542. So, oh, it's a bad 5. 2542.4, and then x. So we have this is my y, this is my x. Same formula. Here's my lower, 44.7 plus, oops, this is my 2, and this is my 1. So we have 2542.4, 2544.7, 0.35, 0.06. This is my x, 0.2 minus 0.06. So plug it in the calculator. 2542.4 minus 2544.7. You can also do this in the video, follow along, see if you get the right answer. I got 2543.589.655 kilojoules per kilogram. Another note that you want to make sure is when you're doing these calculations, keep the whole number in the calculator, and when you're done with the problem, round up to the nearest sig fig, which here we have, let's see how many numbers we have here. We got 1, 2, 3, 4, 5. Yeah, 5. So, but when you're doing intermediate calculations, make sure you have this completed. Okay, so now we have this one, which is ready. So now what do we do? Well, we've completed the bar. So let me change the color here. Let's keep it green. Yeah, green's fine. So now we have 0.2 bar constant, and now we have temperature and internal energy. This is kilojoules per kilogram. This is Celsius. So now we have this one, 95, and we have 80 and 120. So 80, 95, 120. We don't know what this is, but now we know we have a 120 43.58955, and then 80 is 2485.56206. Lastly, we can interpolate here using the same formula. 85.56206 plus we have this is my y, this is my x, so this is my lower, so this is my 2, this is my 1, so 25, 43, 655 minus 85.56206, 120 minus 80, times, I run out of room, times 95, this is my x, 80, we plug it in the calculator, $24, 85.5626, 120, and 95 minus 80. We have final answer of 2507.320608, but like I said, you need to round off. You need, oh, this is kilojoules per kilogram. You need to just keep it as we do it. So we're gonna round up to these numbers. So the final answer will be 2507.32 kilojoules per kilogram. This is our final answer, and it's correct. Thank you for checking out this video, and I'll see you in the next time.